Have you ever tried to sit in your favorite chair only to find someone else already sitting there? You have only two options there. You can either wait for them to leave first and then sit, or you can push them out immediately as you take their place. This simple situation will explain you the whole type of SN1 and SN2 type of substitution reaction. Welcome to the world of haloarenes and haloalkanes. These two approaches represent our substitution reaction mechanism. Here is the exciting part. In these reactions are there in every NEET, JEE, BITSAT, CUBE and whatnot. If you are taking any question paper, these reactions will be there. That is nucleophilic substitution reaction. So at the end of this video, you will master this concept and I will guarantee you will walk into your examination hall with full confidence, ready to tackle any kind of substitution question they throw at you. Let's get started. If I'm comparing SN1 and SN2, the core principle is same. They want to replace one of those group with another group. What they are replacing? It replaces leaving group. And who is replacing? The nucleophile is replacing it. What is nucleophile? These are the electron-rich species. Electron-rich species. So, obviously what this will do? This will hate the electrons. Correct? For example, OH minus or our halogens, Cl minus, Br minus, F minus, I minus, whichever having more electron in it, they are nucleophiles. Okay, so we already know about what is nucleophile, what is electrophile in our 11th grade. Now we are starting with the mechanism. In SN1 and SN2, there are two questions you have to ask. When does the carbon leave the group and for the bond breaking happen, and when does the carbon nucleophile bond is happening? These two questions answer whether you have to choose SN1 or SN2. Okay, so let's start with SN1 mechanism. This is a type of wait for them to leave first. The previous analogy I have told you. The carbon leaving group bond breaks first, forming a carbocation intermediate. Right? The carbocation intermediate has been formed. Here Br is our leaving group. Okay, the point to be noted is this is a slow step part. This is a slow step process, which means that this is the rate determining process. Always in any mechanism or in any reaction, the slow step is rate determining step. Okay, so what is rate determining step? So the number of substrate, number of molecules participate in the rate determining step, that will equal to the rate of the reaction, speed of the reaction. That will affect the speed of the reaction. Okay. So what will happen in the first step? The leaving group leaves. Okay. After that, as a step 2, the attack of nucleophile happens. Attack of nucleophile. Which is nucleophile? In the first step, we took H2O, right? So H2O, in the presence of H2O, it happened. But nucleophile is not participated in the reaction. Only the substrate is participated in the reaction. In the second step, this H2O part is combining with, it's joining with, making a bond with the carbocation. Okay. In that case, oxygen gets plus charge. As a third step, the deprotonation happens. Okay. This is a 3-step, or you can write it as a 2-step process also. First step is leaving group leaves. The second step is attack of nucleophile. Okay. So this is a 2-step process. Okay, ma'am. But in the name we are mentioning SN1, but you are saying 2-step process. What is the meaning of 1 there in the name? 1 is because I told you, right? The rate of the reaction is unimolecular. This is a unimolecular reaction. So let's see how the kinetics goes this is a graph between energy and the progress of the reaction. It starts from Rx and reaches the threshold and the first intermediate form. Intermediate, which is a low energy species compared to the substrate, or not substrate, compared to the transition state. Okay, so this is our carbocation intermediate, and then finally our product is formed. Cool. So this is a very important graph whenever they are asking about SN1 reaction. Either they will give you the graph like this for the protonation step included, or they will give you the graph like this. Okay, this is starting from the reactant, ends with the product. This bent is our carbocation. Okay, cool. So I told you, right, the rate determining step, the first step. So what is the significance of that? So the rate depends on only the substrate concentration. So how I can write it? Rate equal to, or rate is proportional to concentration of the substrate. So what does it mean? Let's say if I am doubling the substrate concentration, that will lead to the rate doubles. Okay, and if I am doubling the nucleophile concentration or making any changes in nucleophile concentration, then it won't affect the rate, because rate is directly proportional to substrate only. Okay, so that is about rate of the reaction. So remember, in SN1 it is a first order overall reaction, and 1 represents unimolecular reaction, nucleophilic substitution unimolecular. What about the stereochemistry? What type of product is formed? Here you see the leaving group leaves. This is the first step, and the nucleophile attack this carbocation, right? So attack can happen on top side or the bottom side. This is the example of top attack. So what will happen? Bromine leaves from the top, nucleophile attacks on the top. So retention in configuration. This is same as the reactant configuration. Okay, that's what retention in configuration. What if it is attacking from bottom side, opposite side of the leaving group? Then it will take inversion in configuration. It is just opposite to the reactant configuration. Okay, so there are two types of stereochemistry possible: retention and inversion. Cool. So retention plus inversion, what will it will become? So both will combine to form racemic mixture. 50% of retention or 50% of inversion means that would form racemic mixture. Okay. Moving on to solvent effect on SN1 reaction. The choice of solvent dramatically influences the SN1 mechanism. For this reaction, polar protic solvent. Point to be noted, polar protic solvent. What is that, ma'am? Protic means hydrogen containing solvent. Say for example water or alcohol, which is having OH group, no? Alcohol or carboxylic acids. They are polar protic solvent. Protic solvent can be of non-polar also, but here we are mentioning polar protic. Each of these attached with the more electronegative oxygen, right? Which makes the compound polar. Correct. So polar protic solvent favors SN1 reaction mechanism because they have high dielectric constants, right? That stabilizes the overall charge, because carbocation step is a major step in SN1, and they can form hydrogen bonds with the leaving group, helping it to depart. Correct? and they can stabilize the carbocation through the solvation. We already saw H2O leaves the compound, right? So this helps to make it leave the compound. In exam questions, when you see the tertiary halide in polar protic solvent like ethanol or water, SN1 should be your immediate answer. Okay. So moving on to the next factor affecting SN1, that is nucleophilic effect. For SN1 reactions, this is also plays a very important role. Ma'am, you told nucleophilic concentration will not matter. Nucleophilic concentration will not matter. But what type of nucleophile you are taking, that matters. Okay, here we are taking weak nucleophiles. Okay, and the common examples are H2O. These are not only solvents, this can act as a, sometimes it can act as a nucleophile. OH will act as a nucleophile in H2O, ROH or carboxylic acid. So the nucleophile strength does not affect the rate, but it affects how the reaction happens. Please remember, in SN1 reaction, the nucleophile does not participate until after the rate determining step happens. So its identity does not affect the reaction rate. This is why the solvent itself often acts as a nucleophile. Okay. Moving on to the practice. So as I always say, practice is more important. That's why I'm attaching the DPP in the description or in the first comment. Please do attempt those questions that day itself. Okay. So at the end of the whole chapter, we'll be discussing whatever the questions you are asking it in Ask Your Doubt portal. Okay. In our ChemCrack, you have Ask Your Doubt portal where you can scan and upload your questions. Your answer will be immediately sent to your mail. Please make wise use of it whenever you are practicing questions. For that, first you have to practice the question. Okay, cool. The first question is that hydrolysis of tertiary butyl bromide. Tertiary butyl bromide. Right? So I'm doing hydrolysis. So what it will form? It will form, first it will form the carbocation. Carbocation is more stable over here. Ma'am, why tertiary butyl? What if I'm having secondary? What if I'm having primary? Right? So that question is also having in your mind. It's there in your mind. So substrate effect is also matters. Which carbocation is more stable? Tertiary carbocation is more stable, then comes secondary, then comes primary because of inductive effect, right? And then comes methyl. So here in SN1, this is the order of SN1 reaction. Because once again I'm telling you, carbocation formation is a major step in SN1 reaction. So tell me what is the product formed over here? So which is tertiary butyl alcohol. Correct? Then the next question, which is 2-bromo 2-methyl propane in ethanol. Can anyone tell me what is the answer to this question in the comment? Just pause the video and then put it in the comment. Ma'am, we have not enough solved the questions. Okay, don't worry, we will solve it. This is propane. So 1, 2, 3 carbons, right? 2 methyl. Second position I'm having methyl group. Second position I'm having bromo group also. So remaining I'm filling it with hydrogen. With ethanol. I told you, right? Ethanol is a polar protic solvent, and also sometimes this act as a nucleophile as well. Cool. So this is our nucleophile. So what would be the product? Bromine is replaced by OH. Okay, tertiary butyl alcohol is our product. Sometimes they will give you the nomenclature and ask you to find the product, or sometimes they will give you the structure itself to find out the product. Okay. Moving on to the next question. Which of the following gives fastest SN1 reaction? So what is the order? Tertiary, secondary and primary. So first one, which is methyl. So methyl group will never give SN1 reaction. And then comes the second one, which is secondary carbocation, and C option, which is primary, and this one is tertiary. So the fastest one is tertiary, option D. Which of the following gives fastest SN1? 1 second. Reminding you guys, this is not phenyl ring, these are cyclohexanes, right? Okay, the first one, which is again primary. The second one, here I am having 1, 2, 3 groups attached and then bromine. So which makes it tertiary. And this one, which is CH2Br, right? Which is primary once again. And this is also primary. So which will give you fastest? That is tertiary one. Okay, this question is asked in JEE Main 2018, right? The solution of -1-chloro-1-phenyl ethane in toluene racemizes slowly in the presence of small amount of tin chloride. Okay, due to the formation of. Question is so big, I don't know what is tin chloride is and what they are talking about is. This is very simple question. They just mention it is undergoing racemization. SN1 undergoes racemization, right? Racemic mixture is formed. So the reactant given is 1-chloro-1-phenyl ethane. 1-chloro-1-phenyl ethane in toluene racemizes. So what would be the product? What would be the why that is forming? Why that is forming the racemic mixture? Because of carbocation formation. Okay, so why the carbocation formation step is more important? So carbocations are planar, right? So it can facilitate top attack also, bottom attack also. So that's why the racemic mixture is formed. In the next question, consider the following bromides and the correct order of SN1 reactivity is given as. Okay, so this is primary, this is secondary, this is also secondary. There is no tertiary, but here is your clue. Wherever the double bond comes nearby the charge, this can undergo resonance, right? So let me name it 1, 2, 3. So which is more? 3 undergoes faster, then comes secondary, then comes primary. 3, 2, 1. 3, 2, 1. Option D is your answer. Now we are delving into SN2 reaction. So which is the push them out immediately approach from the first analogy we used. So let's analyze the mechanism first. So how it proceeds. Let me take this as a substrate. This is CH3Cl. Okay. So push them out immediately. What does it mean? It is just going, went there and sat in the same place so that who was sitting in the chair, they will move out. Right. So that's the same thing happens over here. The nucleophile approaches from the back side of carbon leaving group, carbon Cl group. Cl is our leaving group over here, and this attacks back side. We used to give the usual analogy for SN2 like Kattappa kills Bahubali from the back side, right? So the same analogy, you can remember it also. Backside attack happens in SN2. As the nucleophile get closer, it begins forming a bond with carbon like this, the transition state. The carbon transition through the trigonal pyramidal geometry. This follows trigonal pyramidal geometry. Okay, which will have 5 connections. Now carbon can only form 4 bonds. Yes, that is true, but this is the transition state, which is taking a trigonal pyramidal connection of 5 partial connections, not a full bond formation. Okay. Now the leaving group leaves. The Cl leaves the compound. So OH settles there. Okay. So this is a single step mechanism. It happens throughout. If that is happened as a single step, so which will be determining the rate? So the rate is determined by both substrate as well as the nucleophile. See here. The nucleophile attack happens, formation of transition state and then the product formation, as simple as that. So the rate is proportional to substrate as well as nucleophile. If the concentration of nucleophile changes, the rate will change. Substrate is changing, the rate will change. Okay, there is a single hill energy diagram only for SN2. What if I am doubling either of the substrate? Let's say I am doubling the nucleophile concentration. What will happen to the rate in SN1? Just put it in the comment. Okay. I'm telling you, if I'm doubling both, the rate will quadruple, like 4 times that will increase. Cool. The next thing we are going to see, that is substrate effect. In SN1, we told you formation of carbocation is there. So which carbocation is more stable? Tertiary. So that favors SN1. But in case of SN2, here there is no carbocation step. If I am having tertiary, that will lead to crowding. Right. So the backside attack, it won't allow. So that's why methyl comes first, then comes primary, then secondary, and then tertiary. Here the tertiary is almost never happens. Okay. Why? Because of steric hindrance. It is making a crowded environment over there. Okay. So what can be asked as a question? When you see the primary halide, your mind should go to SN2. The next one is stereochemistry part. In SN1, it formed retention and configuration. And inversion also, both are forming racemic mixture. Here, backside attack is happening, only one attack is happening. So, which means it is just an inversion in configuration only. Okay, 100% inversion happens. Okay, so the effect of solvent. Here we have to use polar aprotic solvent. Polar aprotic solvent. What is polar aprotic solvent? Hydrogen will be there, but not with the more electronegative atom. Say for example, acetone. Acetone or DMF or DMSO, dimethyl sulfoxide, or acetonitrile. So these are the best polar aprotic solvent, favors SN1. Why it needs to be polar aprotic? First of all, it need to be polar so that it will be enough to dissolve the ionic compounds. They lack in hydrogen bond donors that would cluster around and then shield the nucleophile. And third point, this leaves the nucleophile naked so that it becomes more and more effective and reactive. Then nucleophile effect on SN1. And for supposed to be SN2. Okay. In SN2, it favors strong nucleophiles, especially the anions. OH minus, Cn minus, Rs, I minus, acide. So these are some strong nucleophiles. The nucleophile strength is directly affects the rate. So the strength is also important. And bulky nucleophiles are reacting slowly. As I told you, bulkiness, the crowd should be avoided. SN2, it's like a VIP treatment. Okay, there should not be any crowd. Okay, let's solve some problems. An SN2 reaction at an asymmetric carbon of a compound gives. What is asymmetric carbon? Which is not having any symmetry properties. Let me take a carbon like this. So what that will give? SN2, what will that will give? Only one stereo isomer. So option D makes it right answer. So let's revise whatever we have seen in single table. Please take a screenshot of this table. This will be super important. Very, 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 very important. Okay. It is just, I'm not going to repeat that again. So just take a screenshot of. These are the practice questions I would recommend you to do. If you need more practice test, practice DPPs, I'm giving you the link in the description. Guys, if you don't know what is DPP is, that is daily practice problem. So for each of these sessions, you can go there and practice those questions. Okay, so you can be preparing of NEET, you can be preparing of JEE Main, or only for board exams. All different types we have separate DPPs. You can go there and prepare for your respective examinations. So for your preparation, you can take a screenshot of these questions, these 6 questions. If you have any doubt, you know where to ask your doubt portal. Okay, cool. So this class ends here. So we'll see more about haloalkanes and haloarenes preparation and properties in the upcoming session. So please stay tuned.